Welcome to the Dota Workshop Blender 3D modeling tutorial. I've been wanting to make this for a while now, but I just never had the time. So I guess with my recent break, I guess if you want to call it, I decided to throw this together. So here we go. So the first thing you want to do, obviously, is come up with an idea. And so, what do you want to make for what hero in a sense? And so the best place to start is this Dota 2 Workshop Requirements website, which Valve made for us. And essentially what it is it's just a budgeting list of everything that you could possibly need. So for example, if I wanted to make something for Necrolite, which I'm going to be doing that in this tutorial, I would go to this page, I'd click on his profile, I guess, read his bio, stuff like that. Stuff like this is important. And then what happens is it gives you these budgets, and these limits correspond to the maximum polygon limit, in this case triangle limit, that you can use when you're modeling. So keep this in mind. This is very important. Also, it gives you the texture size limits, which will come in handy later on as well. Most importantly, though, they have already decompiled a lot of the models for us, such as like right here. If I click this, it lets me download this Necrolite model. I've already downloaded this, so I'll show you exactly what happens. But before I do that, I'm gonna explain some other things here. So this website gives you an art guide, texture guide, shader guides, really nifty things to explaining character design, how Valve goes about making their materials and whatnot. And if you, I would definitely recommend reading all of this. It gives you some good insight on how to make quality models. And if you scroll down past this hero list, it explains a lot of the guideline submissions and everything like that. So yeah, I guess we can get started now. Unless this tutorial probably won't cover hugely complicated things like animations and stuff like that, but it's good for getting started. So once you have your file downloaded, it'll look something like this. It'll be like a models and material source folder, and if you open both of those up, one will have access to the SMD files, which are not in that folder, in this folder for some reason. But anyway, SMD stands for, I think, source model data. Don't quote me on that, but essentially it's just Valve's way of using their model. You can compile these to .mdl files later on. These are handy because Blender can actually work with these. There doesn't exist an FBX importer, and there are no Maya importers either, so the ones you want are the SMD files. And then the materials folder contains all of the TGA files, essentially the textures. So we can look at a bunch of these and see how Valve textured their stuff. One thing to note is that even though Valve was nice enough to decompile a lot of this stuff for us, I've noticed that sometimes a lot of this stuff doesn't work. And what I mean by that is when you import the model into Blender, you'll get a nice import. For example, I'm going to go and import the Necrolite model. So I'm just going to go to my desktop, and where was it? Models, Heroes, Necrolite. So let's just import him. You'll notice that it imported fine, and by fine I mean I only imported the very base model for him. But the problem is sometimes these bones, which is essentially what you use to attach certain parts of the model to the bone so that animations can work properly. Some of these are rotated at very odd angles, and so a lot of the times you won't be able to export your model properly. You'll have very weird rotations. So I did a little bit of Google searching, and I found a very neat. Well, before I Google searched, I tried decompiling the models myself, and it ended up not working out properly because of the fact that there was this very small thing that I missed. And this guy named Vikram, Vic's blog, I guess, he put together a decompiling tutorial. Up to, I'd say, this part is where you want to go. So right where he ends with the studio compiler, that's what you want to do. If you're having trouble later on compiling it at the right angle, instead of just using the files that Valve gave you, decompile your own model. So you're going to need a studio compiler as well as Blender and Photoshop and whatnot. Okay, so now that I've made my spiel about that, I'm going to quickly go over what programs you need. So obviously you need Blender. So I would blender.org, download. Any version of Blender works. I personally use 2.62. I recommend the zip file and not the installer. It allows you to install it wherever you want. You need SMD tools to go with that. This allows you to import and export SMD files, which is what we'll be using to compile using the in-game compiler. Important note is that the SMD tools version must match the version of Blender. If they don't match, it won't work. So make sure to install this correctly. The way you install it is it's pretty simple. You download it. It'll give you a little zip file with Python files. Let's see where you'll essentially take those and put them in your Blender folder, the 2.6 scripts, add-ons, and you'll find it here, IO SMD tools. Just drag that into this folder, and then when you're in Blender, just make sure to go to File, User Preferences, go to Add-ons, and scroll down to Import Export SMD Tools, and make sure that this box right here is checked. This allows it to run every time the program starts, and you can save that as default. Okay. So once you have Blender and SMD Tools installed, you can go ahead and close those, and then you'll need Photoshop. In the past I used to recommend GIMP and Paint.net and stuff like that, but really Photoshop is the way to go. It just trumps all the other image editing softwares out there. It's just a brilliant program. So I recommend getting that for your image editing needs. Let's see here. Okay, so yeah, again, I'm going to start by making a Necrolite model. So the very first thing I do, again, go to this technical requirements page and say, oh, okay, I want to make a Necrolite model. So I go to his profile. Actually, I hate Necrolite. I hate this hero. I don't even know why I'm making this. He's like such a... God, he's so hard to lane against. Anyway, so I'll go to his page and be like, what do I want to make? I'll make a scythe. So I go down here and I say, okay, weapon, 500 triangles, okay, and then the texture 256 by 256, okay. And it tells you there's an important thing down here. It says this model should primarily be bound to the bone sickle 1. Okay, so I'll keep that in mind, and I'll explain this when I'm actually modeling. So I went ahead and downloaded this. It actually didn't work for me, so that's why I noted the Vic's guide to decompiling models if you're having trouble with that. So I'm going to go ahead and actually start a new file here and import my own decompiled version of Necrolite. Alright, and so you'll notice that the pose is actually a little bit different, and he has all his items attached to him. But the most important thing here is to notice that this bone right here, which happens to be just correspond to sickle 1, if I show names, it's actually in a little bit, it's rotated in a different position than it would normally have been in. So that was actually what was causing my problem, and once I figured that out, it wasn't too bad to export in the right orientation. So the next thing I want to do is I want to go ahead and make the actual model. For this tutorial, it's going to be a little bit different than my TF2 one. I'm going to assume that you know actually a little bit about Blender to begin with, so I'm not going to go through like the entire basics. But what you'll want to do is you'll want to make your model. So if I was making a scythe, for instance, I would start with a cylinder. Dota modeling is generally much less polygon intensive than TF2, so I'm going to change this to 8 vertices. So let's scroll this up here. You have to be very cautious with the polygon budget, because what you essentially have to work with is much less than what you can work with in other games like TF2. So I can only have a maximum of 500 in this case. So I'm going to start off by rotating this, making it a little bit bigger. Just generally doing whatever it is that you normally would model, etc. I'm actually going to skip this part because I actually already made a scythe, so I'm just going to import that. Alright, so let's just go ahead and import my scythe. Let's go with this one. Yeah. Okay. So I'm just going to go ahead and hide some of this stuff. So this is the, whoops, that didn't do the trick. 1 second. Let me just go ahead and delete that. So this is the scythe that I ended up modeling. You'll notice that it's the Scythe of Vice from in-game. I decided to do this because I thought it would be a fun thing to make. So once you have it modeled, essentially what you're going to want to do is select your model, and you're going to want to unwrap it, obviously. So go ahead and do the normal unwrapping procedures by creating seams and by projection unwrapping. So my favorite way of unwrapping things is by simply projection unwrapping. So for instance, if I wanted to unwrap this part of the blade right here, the quickest way to do that would be to first of all hide all this other stuff, and then show only this side of the face, and go ahead and select this whole face right here. Okay, and you'll notice that since I only had one face selected, it only selected this part, well, excluding these. Actually, that's the same one. Okay, so ignore that for now. And then what you can do right now is essentially just project this face onto the UV coordinates by hitting U and then just project from view. It'll essentially just project it right there from view. And you can repeat that for the rest of the model. It's very useful for like organically shaped things, but for instance, something that's very cylindrical like this handle, you wouldn't really want to use projection unwrapping for that. You would want to just go ahead and mark maybe a vertical seam and just unwrap it like you normally would. The next thing you would want to do is you want to go ahead and bake this. There are different types of maps, I guess you would call them, for a model. You have the ambient occlusion, the color, the several masks that you'll create later in this tutorial, and a light map, which a friend showed me how to do. His name is HellJumper's, showed me how to light map. Really very useful in texturing, and I'll show you how to do that later as well. So go ahead and create an image for this. New image. Make it about 4 times larger than the final texture size is going to be. So in this case, if I want to make 256 by 256, go ahead and make it 1024 by 1024. Okay. And then from here, what you want to do is you want to bake your image, baking it ambient occlusion wise. So make sure you go to the render tab, scroll down here, choose ambient occlusion for the bake mode. You can either normalize it or not. I like normalizing it. It allows me to have a much whiter texture than gray. So set the margin size to 6. Then go ahead and click the World tab. Scroll down, make sure that ambient occlusion is checked in this drop-down menu right here. Go down to Gather, choose Approximate, turn on Pixel Cache, and then slide down the error to about 0.25 and the correction to 1. And then from there, what you can do is you can just bake your image, and it'll give you a baked AO file. So you'll be able to see it like this. It's important to note though, I forgot that I had overlapping UVs. If you do have overlapping UVs, make sure to drag them out before baking, or else you'll get some artifacts like this. It's not too bad for our purposes, but just don't forget to do that. The next thing you'll want to do is you'll want to save this image. So go ahead and save that by going down here in File, Save As, and save this as a TGA, so Targa. Save it wherever. Once you've saved that, go ahead and export the UV layout as well, and export that. And once you have those two files, the modeling step is mostly over. We'll come back to positioning and everything later. Now what you want to do is you want to go ahead and start texturing this thing. So I'm going to go ahead and open up my Blender projects. So for Necrolite, I'm going to open up my AO and my UV. Okay. Oh, whoops. Let's open that up in Photoshop. There we go. So here's the bake that I did previously and the UV data. So if you overlay this on the AO and set that to overlay, you'll know that it just shows me where my everything lines up, essentially, where all the vertices line up, so I can better texture my model. So from this point, what you want to do is you just want to go ahead and texture your model. There are several texture guides available. Valve has one up on their website, as I mentioned before. Right here, this texture guide PDF. It's a pretty big PDF that explains a lot of their design features and whatnot. So you can just go ahead and check this out. I mean, really what it comes down to is, are you good with Photoshop, essentially? So go ahead, create your color layer is what they call it. And once you have your color layer finished, let me actually pull up the finished color layer so we can see how that looks. Okay, so imagine I've finished coloring it. So at this point, it would look like something like this. The next thing I want to do is I want to go ahead and render a light map to give it a little bit more detail. And so in order to do that, what you'll want to do is you'll want to create a normal map first. And so a normal map, essentially what a normal map does is it gives you the illusion of depth by the way light hits the model. And so it's a neat trick to making it look more detailed than it actually is. And so what you'll want to do is you'll want to install this nvidia tools filter, the filter for your version of Photoshop. And what this allows you to do is it allows you to create easy normal map textures right from within Photoshop. So I'll link to this in the description. So once you have that done, what you want to do is you want to flatten your image so that you have this background layer. Go ahead to Filter, nvidia tools, normal map filter. From here, these are the settings I use. It's a 4 sample, a scale of 15, and average RGB. I mean, you can take a little bit of time to look this over, but essentially this is what it comes down to. And when you hit OK, it'll just basically give you a neat-looking normal map. So go ahead and save this normal map. So file save as TGA, save that, and then go ahead and open up Blender. And instead of loading up your AO file, load up the normal map instead. Well, actually, before you do that, sorry, that's not what you do. Go to this Materials tab. You want to make a new texture. So if there's already one there, just go ahead and remove it. Add a new material. Call it whatever you want. At this point, it doesn't matter. What we really want is just to get a light map in. Go to the Textures tab, add a new texture, go to Type, Image or Movie, and then down here, open the normal map that we just created. Okay. So you'll see it shows up here. So then we need to change a couple of things. So go down to Image Sampling, select Normal Map, go down to Influence, remove this from Color and change it to Normal. See if there's anything else. Go to the Mapping tab, this drop down, and select UVs in this coordinate screen. And then that should be it. We can check to see if it worked if we scroll our cursor into the main 3D view and hit N, the N key, and scroll down to the where is it? Display tab. and find the shading subheading and change that to GLSL. Okay. Now it'll look like this in the textured view. It's completely black, and so what we need to do is we need to add some lights to the scene, point lights to be specific. So go ahead and Shift A in the main screen and add a light, point light. And so you'll see that it's kind of dark, so I'm going to go ahead, select the light, go into the point tab, and change the energy to, I don't know, let's say 100. Okay, so now it's really bright. So I'm just going to move this around. And what you're going to do is you're going to want to make several of these and just move them around. So what we're going to do is we're basically just making a point, or what do they call this? Light map. Yeah, light map is the name. And this is just to give us some extra depth to our texture, as you'll see soon enough. So I'm just Shift D. That's just to copy paste basically these lights. Let's tone this one down to 50. Maybe another one over here, maybe. Obviously, this would take a lot more time when you're actually doing it. But just for the purposes of this tutorial, I'm going to stop at this point and say, okay, now it's done. I'm just going to go with it. So we're going to render another map. Instead of an AO this time, we're going to render a full render. So go into the World tab and make sure that this AO is off this time. Then go back into the Render tab, and instead of ambient occlusion, choose Full Render. Go ahead and bake that. And you'll see that it created a pretty nice texture. Again, I forgot to move these UVs, so I'm going to do that real quick. These are duplicate UVs. Oops, I'm going to move them out, bake this again, and then when it's done, I'm just going to move them back in. It should be not too bad. Okay, so that's much better. And you'll see that now we have a very nice light map rendered out here. It's actually not very nice. I would use a lot more light in this case, but for the purposes of this, it should be fine. So go ahead and save this. So save as image. Go ahead and save that. I already have one made, so I'm just going to show you how it looks like. Actually, so here's the. Okay, let me open up how it actually looks like. Okay, so here's the full render by itself, the one I had made. And when I do pull it into my finalized texture, what I do is I have it set to soft light at 90% on top of everything else, and you'll see that it kind of gives you a much nicer addition. It kind of highlights certain things, darkens certain areas, gives everything a nice texture. And that's the purpose of this light map, is to give you some nice overlying textures. So once you have your color map created, go ahead and downsize the image to the restrictions. So for mine it was 256 by 256 as denoted by the technical requirements page right here. So make sure it's this size or else it will not compile. Go ahead and save this. Also go back to your normal map that you created and again save that as 256 by 256. And what you're going to want to do is you're going to want to name it a very specific thing. So you have a base texture name, as you'll see here. I named it Scythe of Vice 256, and then the end part is important. You're going to want to do underscore color for your color map, underscore normal for your normal map, and then you have these other two masks here. And these masks are a little bit confusing at first. Essentially what they are they're just ways of giving information to the source engine for shading information. They're all explained here. So you have what I was talking about, the color map, the normal map, and then mask 1 and mask 2. The normal map is just for, again, what I said, it's lighting, color, that's the color, really simple. And mask 1 allows for these 4 things. You'll have 4 channels, R, G, B, and A, and those are found here, essentially in a 32-bit TGA, you'll have four channels: the red channel, the green channel, the blue channel, and the alpha channel. So you'll see, for example, let's go to the mask one, that different channels correspond to different things. So the red channel in mask 1 is the detail map mask, the green channel in mask 1 is the diffuse, the blue channel is metalness, and the alpha channel is the self-illumination mask. Make sure you read up on exactly what you need to do. It's on the technical requirements page right here. There are certain things that you need to make sure that you don't forget. Like, for instance, the alpha channels are required on mask 1 and mask 2 regardless if you're using them. So for instance, I didn't use a mask 1 channel or an alpha 1 channel in my mask 1 texture. So, but I still needed to have it, so in order for the engine to not throw it out, I had to just basically have a certain pixel of black in the corner or something like that, just to make it so that the engine doesn't think that it's empty. So essentially, just make sure you read this. It's important. So once you have your masks created, the easiest way to make these masks is just to look at what Valve does to a default weapon, for instance. If you're having trouble getting the shading correct, Valve has provided us with their source files, as I explained on the website. If you just open those up, for instance, if I was having trouble with the mask 1 for the weapon, I would just open this up, and I would say, okay, well, it looks like the channels are just completely all black, so I'm just going to go ahead and mimic that, for instance. And you'll see again here is what I was talking about with we don't want the alpha channel being thrown out, so there's something there. This mask 2 will be a little bit different, so they have the textures, for instance, like this. This is actually a very simple example. Maybe I should have found a more complicated example, but it comes down to it comes down to if you're having trouble, just look at what Valve does. They usually do a good job for reasons. So once we have our four textures created, the color, mask 1, mask 2, and normal, then go ahead and save those all as 256 by 256 in a location that's where you can find it. Next, what you want to do is go back into Blender, and we're going to want to get the positioning right. So I'm going to go ahead and change this back to multi-texture, and I'm just going to get rid of these point lights right here. I don't need these anymore. Okay, so I'm going to unhide some stuff here. Okay, so what I like to do is I like to preserve the old bone rig in case I need it later. So I'm going to Shift D this, so I can basically create a copy. Hit 0, enter. That creates a copy. Go ahead and hide it so that we can use the original one. And for this, we know from the website that they told us to use the sickle 1 bone. So I'm going to go ahead and delete everything but the sickle 1 bone. So I'm going to select all of that, go into edit mode, make sure you're in edit mode by hitting tab. Go ahead and select everything, hit delete or X, and delete those. If you don't know which bone is what because you can't see the name, simply select the bone, go into the object data tab, and check this box named names, and it'll show you the name of the bone right there. The next thing I want to do is I want to make sure that my bone is, or my model is located at 0, 0, 0, rotated with 0 degrees angle, and has a scale of 1. So in object mode, this is important. So in object mode, select your model and make sure that these are all 0. If they're not, change these to 0, these to 0, and these to 1. And then you'll get some sort of maybe skewed model. Then what you want to do is go into edit mode and reposition your model. This is done to ensure that, well, to be frankly honest, I'm not exactly sure why this is a necessary step, but it's useful in case you're having rotation problems, just to make sure that this is not the cause of your problem. So once you have that done, then go ahead, go into edit mode, reposition your model in the exact same position as the old sickle, so that he holds it right in game. Then we want to parent this model to the bone, so go ahead and select the sickle first, or the bone, the model first, then the bone. So by selecting the model, then shift-clicking the bone, and hit Control P, and then hit with empty groups. From here, select the model, go into edit mode, select everything by hitting A, and then going into the object data tab, and go down to the sickle bone and hit assign. And so to make sure it's assigned, you can just select everything to make sure it chose the right one. Okay, so once you have that assigned to your model, we're going to go ahead and export this thing. So select this, make sure you named it appropriately. So in this object tab, name it something like Scythe of Vice Blender. Okay, and I'm going to go ahead and file, export this source engine format. It might be named something different depending on your version of Blender, but just make sure it's at the .smd file. So go ahead and export that. It'll ask you where you want to save it to, but I'm going to just choose I already have it exported, but go ahead and choose a folder of where you want. So for example, Necrolite, go ahead and export that, and you'll end up with an SMD. So at this point, if you'll go back to the work folder that you have, you'll notice that you'll have one SMD, so for example, this Scythe of Vice, and then 4 texture files. So from here, you're almost done. You just need to compile it. So go ahead and open up Dota 2. What doesn't? Okay, so in Dota 2, go to the Customize tab, the Workshop tab, go to Publish New Item, Wearable Item, select your hero. In this case, it would be Necrolite. And the weapon slot. So I'm just going to name this like Blender Test. Go ahead and select the geometry. So what you can do is there's the in-game geometry, which actually shows up in-game, and then there's the optional portrait geometry, which shows up in the portrait, obviously. For this one, both max polygon counts are 500. So I'm just going to go ahead and use 1. So here we go. And the texture file. So the thing about this is that you only need to select one of the textures. Here we go. So I've made these 4 textures: the color, mask 1, mask 2, mask normal. You can select any one of them, and it'll automatically find the other 3 as long as they're in the same folder. So I'm just going to go ahead and select color 1. Go ahead and import that. It'll compile it for you, and just hit OK. And if you did everything right, you'll notice that now I compiled the model in game, and so you can test some different animations, like the run animation. You can test different views, like the in-game view versus the portrait view, or nighttime versus daytime, stuff like that. And that's essentially it. So once you're done with that, you go ahead and submit this. I'm not going to submit this, obviously, but you would give it a submission title, like blah, describe it very well, and then the preview image, which is what shows up as the very first thing that people see on the workshop. So when you're done, go ahead and submit that, and you'll be able to see it on the workshop. I actually went ahead and compiled this Scythe of Vice for this tutorial, so you can see it here. At this location. Go ahead and upvote it if you like it, or not. You know, whatever, I guess. So that's essentially it. That is Dota 2 modeling with Blender in a nutshell. Oh, that's nice. If there are any more questions and whatnot, I'm probably going to be making a certain text-based tutorial, kind of like I did in TF2 in the future, just to get the basic process down for people who have already watched this but don't want to watch it again. And so, yeah, that's it. That's essentially it. I hope you found this tutorial useful, and please let me see your finished creations by linking them to, I guess, the Steam group. I might make a Steam group in the future. Please don't ask me questions directly on Steam, though. I get a lot of random questions and it gets kind of tedious, but you know how that is. Anyway, thank you, and I hope you liked my Dota 2 tutorial.